So for the extraction of iron, it's actually not electrolysis that is used, but it's actually the reduction using carbon monoxide. Because iron is less reactive, so we don't need high energy as electrolysis to really extract the iron. We can have like using reducing agents such as carbon monoxide to carry out that reaction, right? Extraction of iron is Fe. Alright? So when you're doing this question in the exam, you have to draw the furnace, alright? Which you have to learn how to do. Alright? Sometimes they will just want you to just show the equations. Alright? But it's good to know how to draw it as well. Alright? So 1900 degrees Celsius here. Then you have 1500 degrees Celsius. So it's very high temperature this end. Alright? And then 800 degrees Celsius. Alright? At the top, alright? Now, here, the ores that for iron is hematite and magnetite, right? Current formulas for these compounds. So the hematite is Fe2O3. While the magnetite is Fe3O4. Alright? So you can go and read about it. Alright? Now, so if at the top, we normally introduce what we call the charge. And what is the charge? I'm going to tell you short. Alright? Alright? It's basically the iron, carbon, and there's the iron ore, limestone, plus carbon. Alright? Limestone, so the ores is the hematite and the magnetite. The limestone is calcium carbonate. And the carbon normally referred to it as coke. But it's just carbon, like carbon solid, pure carbon, right? Now, when they put the carbon in at that high temperature at the bottom here, here I'm going to have carbon solid plus the oxygen gas produce carbon dioxide gas. Alright? When the carbon dioxide come to a lower temperature, it will react with more carbon to produce carbon monoxide. Alright? And then the carbon monoxide is what is reacting with the... Alright? And then the carbon monoxide gas will now react with the iron. Fe2O3 solid produce Fe plus carbon dioxide, right? So put 2 there, 3, 4.
2 at the front, and the carbon. So when they
3, if you 2, 3, and then 3 in front the CO2.
what the acronym for carbon monoxide?
The acronym
What's your name?
CO, the formula
Yeah.
CO.
The same as carbon dioxide.
Carbon dioxide CO2.
Oh.
Monoxide is, so this is carbon monoxide.
Yeah, we put that 3 in front of the carbon here.
And this is carbon dioxide, right? No.
Yeah, we put that 3 in front of the carbon.
Here,
Or single. It's carbon monoxide.
well, let me see. Two they put there, you put 2 here and balance. Alright? Now, why do we add limestone? That's a question that they will ask sometime in the exam. Why do we add the limestone, which is the calcium carbonate?
Calcium.
And the bottom here is molten iron. The top here is the calcium silicate. Which is
Maybe because
CaSiO3.
maybe because of the heat is more reactant with heat. More reactant with heat.
So first, the calcium carbonate is going to break down to calcium oxide plus CO2. Alright, calcium gonna go. Then silicon oxide is an impurity in the iron ores. It's an impurity, right? Calcium. Alright. So iron ore contain a lot of impurities which are not removed before the ores are put in the blast furnace. So the entire thing here is called a blast. Alright. So what happens is that because this iron that is put here, these go here, they are impure. So you will have the impurities such as the silicon dioxide in it as well, right? So the silicon dioxide is going to react with the calcium oxide here to form the calcium silicon oxide, which is called the calcium silicate. Alright? So this is going to produce CaSiO3. Right? So you have to know about where we add the limestone, which is the calcium carbonate, in the mixture. Alright? And then the molten calcium silicate will also come off as a byproduct that is actually useful because they will use this to make like cement and stuff like that. Alright.